Welcome to today's session. So in this session we are going to dealing with the concept of a 0-1 by knapsack problem. So in this 0 by 1 knapsack problem we are having the three variables. So the first variable is nothing but it should be an object, and second one is every object is having some kind of weights, so we need to take the second variable as weights, and we are having a value or profit. So these are the three variables we need to take for the problem of 0 by 1 knapsack problem. Clear? So now I am just taking one more example for this one 0 by 1 knapsack problem. I am just taking more than 3 objects, so I am just taking first object, second object, third object and fourth object. And for these objects I am just considering the weights as for the first object we are taking 2, for the second object we are taking as 3, and third object 4, and weight for the fourth object is nothing but 5. So for these we are having some kind of a profit in terms of values. So for object number 1 we are having the profit as 3, for 2 we are having profit as 4, for 3 we are having profit as 5, and for 4 we are having the profit as 6. So these are the three variables we need to take for doing a problem regarding to the 0 by 1 knapsack problem. So now we need to check the representations of 0 by 1 knapsack problem in a matrix representation. For this 0 by 1 knapsack problem we need to take a matrix representation, and it's purely based on the values which we already taken. So when you observe this one, so the matrix representation with respect to the rows we need to take items as rows, and we need to take weights as columns. So this is the representations of a matrix. And now for this representation, now we are going to take some kind of matrix representations with respect to this form. So we are having the weights as 2, 3, 4, 5. So the maximum weight is 5 and the minimum weight is, for example, let me have to take in any kind of weight will start from 0. So that's why we have to start a weight from 0 to up to the maximum weight. So that's why we have to take in the weight as 0 is the minimum and maximum is 5. So 0, 1, 2, 3, 4 and 5. So these all are the weights. So these are the weights. And the next one is we have to take in the number of objects. So in these number of objects also we are having the maximum number as 4 and the minimum number is always will starts from 0. So that's why the items also, so we need to take from 0 to 1, 2, 3 and 4. So why? Because 4 is the maximum object we have to take in this example. So now, so if I am not taking any kind of object, or if I don't take any kind of objects, so it is also not having any kind of weights. Clear? So that's why we have to take in every column value should be 0. And we already observed if there is no weight, it simply says that we have never taken any kind of object. So why? Because the weight is equal to 0. So that's why the column of the first one is also has to be kept as 0. So this is the matrix representation. So now based on these matrix representations to calculate the remaining number of values, now we are using a tabular formula value. So the formula is T of I comma j is equal to maximum of T of I minus 1 comma j comma value of I plus T of I minus 1 comma j minus weight of I. So this is the formula. So now we need to calculate the value of 1 on 1. So 1 on 1. So now I am just taking the value as t of 1 comma 1. So here my I value is 1 and j value is also 1. Now I am just simply substituting the values. I is equal to 1 and j is equal to 1. So max of t of 1 minus 1 comma 1 and value of I, the I value should be 1 and the value of I, so object value 1, and for this one we are having the profit as 3. So that's why the value of I should be 3. So 3 plus t of I value is 1, 1 minus 1 comma 1 minus weight of I. So I value should be 1. So again we are going for the problem. So object 1, and for these object value as I is equal to 1, the weight should be 2. So that's why we have to take in the weight as 2, that is nothing but 1 minus 2. So the max of t of 1 minus 1 is nothing but 0 comma 1 plus 3 plus 2 of 0 comma 1 minus 2 is nothing but minus 1. So when you observe these representations, we never having any kind of negative values. So that's why we simply considered this has to be equal to 0 or some infinity like this. So now we are going to finding the values of max of t of 0 comma 1 value is 0 on 1, it should be 0. So max of 0 comma, so this value is already equal to 0. So we are only having the max of 0. So max of 0 value should be equal to 0. So t of 1 comma 1 value should be 0. So then we simply write t of 1 on 1 or 1 comma 1 should be, the value will be 0. So like that we need to perform all the actions with respect to this matrix representation. So I am just writing the all directed values of this matrix representation. It should be 3, 3, 3, 3, 0, 3, 4, 4, 7 and 3, 4, sorry, it should be 0, 3, 4, 5, 7, 0, 0, 4, 5, 7. So this is the overall matrix representation table. So now from these table onwards, we have to check the representation of what exactly, which number of objects we need to take. Clear? So for these I am just taking the number of objects here. So we are having 1, 2, 3, 4, 5 objects. Now for these representations we have to calculate the overall number of profit. So when you observe at the fourth object, so here we are only having the 4 objects. So that's why we need to take only 4. So here when you observe this one, so fourth is having the highest value as 7. Whenever you are getting any kind of highest value, we need to check the previous item also. If we observe the same value is existed in the previous value, then the present state of that value has to be deleted and the previous value has to be noted. So that's the main reason we need to take. Clear? So when you observe 7, so 7 is already in 4. Now we need to check if 7 is existed in the previous step or not. When you observe the third object, 7 is already existed. So now we will go for the 7. Clear? So it simply says that it is already existed in the previous state. The fourth object will not be taken into the consideration. So that's why the answer should value be for 4 is, for the fourth value is, it should be 0. So we never take in the fourth value. Clear? So now the 7 highest value should be in the third object. So again we need to check is the highest profit value is existed in the previous value or not. Again we are going. So 7 is already existed in the previous one. So the third object value should always equal to 0. Clear? So then the second value has to be considered. So now if it is in second, then we will go for the first object. Here we never find any value as 7. So that's why we have to take in the second object. and we never taken third object and fourth object. So third and fourth objects are zeros, and we are going to take only second object. So that's why we have to take in the value as 1. Clear? So now when you observe the second object, so in these second object we are having the original profit as 4. Clear? But here the maximum profit is 7. So if we simply take in whatever the profit we are getting minus whatever the object we have to take in, for that object we are having the profit as 4, we need to reduce from the original to the given. So it should be 7 minus 4. So the remaining profit should be 3. Clear? So we already observed fourth object, third object and second object. Now for this one we have to check the remaining object in the previous step. So the remaining value should be 3. So for these 3 profit we need to check the previous step. So when you observe this one, so we are having already 3. So one value is already having 3. Clear? So it should be 3 minus 3. It should be 3. The actual weight is 3 and the occurred weight should be the occurred profit. In terms of profit we need to take, it should be 3. So 3 minus 3 is equal to 0. So every profit has to be considered. So here the third profit of the first object has to be completely taken. So that's why for the first object also we need to put the value as 1. So for this problem we need to take only the first object as in full form and second object as full, and we never take it any kind of third and fourth problems. Clear? So this is the oral representations of the 0 by 1 knapsack problem. Thank you.